Hi everyone, welcome. My name is Mia. I'm one of the producers for TWiML, and we're excited to have you here. This session is office hours focused on NLP, and it'll be moderated by Arshad Mahmood, founder and CEO of Collably. And we have several wonderful guests here to answer your questions on NLP projects. You'll hear from John Bohannon, Samir Singh, Charlene Chambliss, Tom Grech, and Nicholas Egan. Before we get started, I'd like to thank our sponsors for their support of TWiML and today's session. Also, since today's session is hosted on Zoom, please take a minute to note the location of the chat, and please feel free to send any questions through there. We'll be monitoring the chat. And now I'd like to turn it over to Arshad. Enjoy.
Hello, everyone, and welcome to this NLP AMA. We have got some very interesting guests here, and I think I'll just ask them to introduce themselves, which will probably be best. So perhaps we can just start with John and go on from there.
Hello, everyone. Pleasure to sort of meet you. I'm John Bohannon. I'm the Director of Science at primer.ai, and I've brought along some of my very best machine learning engineers and researchers to answer questions. So we work primarily with NLP. We're trying to take deep learning into industry. We can dig into the details together.
I guess I can go next. Yeah. Hi, I'm Samir. I'm a professor here at University of California in Irvine. And I do research in machine learning and NLP. A lot of it focuses on interpretability and evaluation of these machine learning models, how to debug them, how to find problems in them, and hopefully give some users something that they can rely on. So any questions about those would be welcome.
Charlene, how about you go next?
Sure, yeah. So I'm on John's team over at Primer. I'm a machine learning engineer. Things I've worked on have included relation extraction, general information extraction, classification, all those sorts of good NLP tasks. And I've also taken an interest in the operational side, such as data labeling and making sure we have robust data versioning and all that good stuff that makes data science viable.
How about Nick?
Hi, everyone. I'm Nick. I work with John on the applied research team at primer.ai. And at Primer, I've worked on various problems around NLP, such as co-reference, summarization evaluation, factual claim extraction, natural language inference, and model explainability. In the past, I've worked at MIT's Computer Vision Lab on generative models and various technical roles at Robinhood, Facebook, Airbnb, and Priceline.
And Tom. You are muted, sir. Oh no, it looks like we're having microphone problems.
Yeah, we still can't hear you, Tom.
If you are unmuted on the app, then there's something more fundamental at play.
How is that?
Perfect, there you are.
Excellent. Hi, everybody. I'm Tom. I know nothing about computers, obviously. No, I got a master's in AI way back when it didn't work. I founded an NLP startup way back when it didn't work. And now I'm working at Primer, where NLP does work now, which is great. Yeah, I do a lot of kind of low-level deep learning stuff. And you can ask me about ML ops as well.
I should add, Tom's being a little bit shy about it. He's basically made Primer's version of Hugging Face, which basically handles all of our deep learning model training, serving, innovation. It's a fantastic tool set.
Yeah, that's really great. Thanks, guys. So I don't think I've missed anybody out. So actually, my background is that I've come to NLP very late, so only in the last 2 years. But it's just been an incredibly exciting journey for me because with so many of these pre-trained models available that I can actually use on my local computer and I use them from there. So for all the participants, if you want to ask any questions, if you can just put them in the chat, please, and then we'll pick them up from there. And to get us kind of started, I just wondered if I could ask John and the others, what is their kind of excitement or interest in AI, how that developed, and where they think the field may be heading from their perspective, because obviously all of you have got quite varied perspectives on this. So maybe John.
Oh, that's a big one. Well, I'll just set the stage and let the rest talk. You mentioned something that really is quite striking, that you kind of got into this only 2 years ago. I think that's an advantage. When it comes to NLP, everything before 2 years ago is kind of just baggage that's gonna trip you up. Starting fresh from BERT onwards is brilliant. So that I'm gonna make that bold claim, and apologies to all the people with degrees that have the word computational linguist in it. But I'll stand by that. And so anyone else jump on in.
I guess I'll jump in just to disagree with that statement. Not that I'm saying that everything that—
Let's make it spicy.
not that everything that comes before the last 2 years is useful, but I think it's a little bit short-sighted because we don't know how long the advantages of BERT would hold. I don't think we understand exactly what are the capabilities and what are the shortcomings of these models. And looking more essentially at what language means and what kind of variations there can be in language can be extremely useful, and has been extremely useful for our work in showing the many ways BERT is broken. And so having a perspective on the last 2 years sometimes makes people focus even more on the accuracy of the models, which may not always translate to user experience or reliability or any of these other things. So I'm not going to say that we should be ignoring the last 2 years, but there are many lessons to be learned from a much longer time frame, especially when we're thinking about what might be available next rather than what's available now.
Yeah, that's interesting, actually, because that's sort of the conclusion that I'm coming with, in that obviously BERT and the transformers-based models are the state of the art at the moment, but I'm always constantly thinking, where next? So I'm going back a little bit further back to NLTK and WordNet and things which were a little bit more explainable as to what was actually going on. And looking at some of Dan Jurafsky's lectures actually from 2012 and how things were done at that point, and just to get a slightly different perspective, because I don't know, from my uninformed perspective, it seems like we might be in a local minimum, and how we break out of BERT and what it's doing will be a real challenge. But that might be a little bit of a provocative statement. But yeah, I was just wanting to see where, what your guys' perspective was on where we are now, and where we might go. Although it's a big question.
Yeah, I'd like to jump in on that a little bit, because I kind of agree with you. I think progress in NLP over the last couple of years has been extremely rapid, right? We've made some great advances, machines that can do wonderful things, and we're putting them to good application. And I think that's where a lot of the NLP progress is coming now. But I think the field may have stagnated a little bit recently. I don't see where the next big leap is going to come. What we do know is that the language models we have right now don't have common sense, right? They don't have any reasoning abilities. And so when I look to the future, I think, well, for NLP to kind of truly take off, that's where we need to go next. And I honestly don't see currently a path forward to that. I don't see the research going in that direction. Like, what comes after transformers? We just we don't know yet.
Yeah, I agree, and I think my strong stance on you can ignore everything pre-BERT is deliberately spicy. I'm just being silly, but also really quite focused from the practitioner industry perspective. I'm coming from trying to make NLP work pre-BERT at Primer was so painful using tools like Spacia and NLTK with these models that sort of, you had to struggle to get to 80% accuracy on some task. And now that's just out of the box performance. It's really brilliant. It's made NLP fun. That's really the point. But let's drill in on explainability. I think that's actually something where we can have something real to talk about based on our own experience recently. So Nick has actually been working on making models like BERT and really any deep learning transformer, based model that takes in text and forcing it to explain itself. Really, just over the past few days, we've been playing with this technique he's spun up. Nick, can you kind of give a thumbnail sketch?
Well, yeah, I guess like an experiment that I recently ran was seeing if we can use the technique of saliency in order to explain our models. And I think the use case we had at Primer was pretty focused. We basically wanted to pull out a sentence that best explains the classification decision from a classifier model for a whole dot classifier. Particularly classifiers that really are just detectors of certain, I guess, things coming up within a block of text. We're able to get that to work pretty well, which is exciting from our standpoint. Although I know that Samir actually has worked a lot on explainability. I'm kind of curious what his thoughts are on like how we could make our models more explainable and what the future lies for that.
Yeah, no, that's a difficult problem, and I think the more we've been looking at interpretability techniques, it seems like there is no single silver bullet that sort of gives you the right answer for all kinds of questions you want to ask of explainability. I think there are explainability reasons for sort of debugging, or maybe from your guys' perspectives, like whether before deploying a model, is it doing the right thing or not? The types of explainability methods you would need there would be very different for something like auditing or something a little bit more that needs a little bit more certification behind it, or something that you might want to release user facing, right? So I'm recommending this news story for you because of this sentence or something like that. All of these things require very different kind of explanations. And more recently, we've been looking at different ways that explainability techniques may be unreliable sometimes, especially if you think about some adversary being in the loop where they're giving you the model and they're saying, hey, use explainability techniques and you'll see I'm not doing anything crazy. Turns out that most explainability methods are actually fallible in that case. We've shown that recently with saliency map techniques as well, where the gradient, you can arbitrarily manipulate the gradient irrespective of what the model is doing. So those kind of things essentially means that the problem is far from solved, and there are many different ways to sort of go about it. Yeah.
Hey, we just had a good question come in. Let's jump on it. Charlene, this is a perfect opportunity for everyone to meet you. The question, if I may interpret it, is now that we have these deep learning models like BERT, how will we be able to harness them to create structured data for knowledge bases and knowledge graph, the more popular synonym of knowledge base these days?
Yeah, what's interesting about how these transformer models perform for things like relation extraction is it's literally just a matter of like getting enough data for the relation that you're interested in, and you can get state-of-the-art performance for that relation. And we have actually done that for 3 separate relations just by using the question answering paradigm, which actually was Tom's idea, and then I kind of took it to fruition. And so what we did was, we pose a question like, who is the employer of person X to a piece of text that says, person X, analyst at Goldman Sachs or something like that. And then the model can actually grab Goldman Sachs. It knows that. It's very easy as a question for it to answer. But what the bigger challenge actually turns out to be here is that paradigm is actually quite challenging to productionize because you actually have to make many different inferences because for every question that you want to ask on a piece of text, that's one slot in your batch. And so you can only ask up to 8 questions per piece of text in a given batch. And so that's kind of something that we're working on in terms of like, how do we get this inference time down? Do we shrink the number of inferences by doing some kind of triage using classification upstream? Do we shrink the model itself so that inferences are just faster? How do we kind of address that so that we can do many different relations instead of just 1 or 2 at a time without clogging up our our little worker stream in terms of the workers processing the documents.
That's interesting. So, I mean, do you find that the fact that BERT-like models have a limited context is an issue? Because, to get a properly functioning knowledge graph, I'm guessing you need fairly long contexts.
Yeah, so that's actually a great point. One thing that we run into with something like building an employer relation extraction model is that you can't really get temporality using the question answering paradigm, because like it's not very often that someone is mentioned with their title or position or whatever, and also the exact span of time that they're working there. And so all you can really do is try to teach it to understand tense, which it doesn't do quite so well on, at least not at this point.
I have a question for everybody else as well, especially the guests here. Once you have a knowledge base, because as Charlene said, we've had like great success populating knowledge bases from unstructured data. But once you have it, what do you do with it? I ran some experiments myself doing knowledge graph inference, things like that, question answering over a knowledge base, multi-hop, et cetera, but none of that works particularly well. And I my own hope is that someday somebody's going to figure out really how to integrate a knowledge base with language models. I haven't seen that happening yet, not that I'm aware of.
Yeah, that's really interesting, because this is something that I'm very actively interested in. Basically, my sort of stealth company is working on sales engagement, and that's taking a knowledge graph of a company and your product and using generative text to generate sort of communications that would be relevant to them. So yeah, this is a problem that I'm really interested in, but it's really, really tricky. Let's have a look. Yeah, I mean, we mentioned things about data sets. I mean, do you think that that we've sort of exhausted the quality of the data sets, or is that not right? What I mean by that is, I mean, even if you look at the Superglue leaderboard, really a lot of the models are pretty close to human. They're in the mid-80s, getting close to 90%. And I just wondered if a lot of the data sets are really too small, the context is too small, and it's really just not challenging enough for the algorithms. And that one of the reasons that we have problems with the explainability is that the model's doing just something not really that sensible, that to make an explanation would have to do something a bit more sophisticated to say this is really the reason that I'm doing this. What's your sort of perspective on data sets that we have, whether we need better ones or are they pretty good?
I can chime in about this. So we've been thinking a lot about things like that. We've been releasing data sets that are increasingly challenging. And what we recently realized is the part of the problem is not that the data set is small or easy or any of those things. The problem is that the training data set is also being released by the same people who are releasing the test data set. So the annotation scheme and everything is just so uniform across train and test that models are pretty easily at this point able to come pretty close to human accuracy, as we can see in these leaderboards. But they're not actually doing the task that they are supposed to be doing, right? And so we have a paper recently on checklists that shows even tasks that have been conventionally like sentiment analysis that have, from a research point of view, most people think of it that as solved. On Glue and stuff, it looks pretty solved. There are commercial products by Microsoft, Google, and Amazon, and everybody else who does sentiment analysis and selling it to users. But all of these models are trained on very few data sets. and have fundamental problems when you just sit down and start playing around and writing your own stuff to test whether these things actually understand sentiment or not. And when you look at other tasks in Superglue, like paraphrases and NLI, which are a lot more, I would say, at a higher cognitive level to some degree, even those look as accurate on Superglue, but when you actually play with those models, you literally have to spend 15 minutes to realize that none of them have actually solved the problem. And but the leaderboards say otherwise, right? So I think the problem is not just not enough data sets or more data sets. The point is, are you just straight testing on what it has already seen on training? Not exactly, and not the same exact phrasing. So not string matched, but fundamentally the same sort of data.
We've had the exact same kind of enlightenment moment at Primer. We started off with the standard data sets like ConLL for NER and so forth. And these old academic data sets that have been kicking around and treated as gospel. And then you sort of dig into it and then you take a look at the behavior of models that, perform at so-called human level on these things. And you realize that they're usually pretty rubbish. It's like a good starting point, but sentiment analysis is a case in point. You're spoiled for data in terms of volume on sentiment analysis. There's a data set floating around right now on the internet of Amazon reviews that's on order of 100,000 examples, where they've taken the star rating and used that as a proxy for the emotion being expressed. And you can do a really good job at predicting the stars of a restaurant or a product review for sure. But then as soon as you try and take that model and do anything actually interesting beyond that use case, it's absolutely useless. It's just you wouldn't trust it at all. And so what we've found is more and more you have to just make your own data sets the hard way. We work with a startup called Odetta that has professional data labelers, and they do way better than we do. When it comes down to it, data labeling is really hard, and defining a task is even harder. You have to make it diverse and challenging and high value and unambiguous. You can't crowdsource these things anymore. That's the take home I've gotten.
So
I'm gonna, in the interest of time, maybe I'll share my screen and just talk maybe a few minutes to show you some of the results we have on the sort of topic we're talking about. So ignore the left-hand side of the screen, only focus on the right-hand side. Here are some sort of tests that we played around with that are fun to look at for sentiment analysis. So here, the original input was the nightmare continues. We picked a neutral word and replaced it with another neutral word with Bert. So it became our nightmare continues. And what we expect is that the prediction should not change that much, right? Like if it thinks that the original is negative, it should stay negative. If it's positive, it should stay positive. And here we tried a bunch of existing commercial products as well as sort of Bert and Roberta and things like that, and realized that 20% of the time, for example, Google fails on this. So when you replace it with another neutral word, the sentiment of the model changes for this input. In fact, this is a problem because you can do more crazier things, like you can add negative phrases, like whatever the original review is, I'm going to say you are lame on top of it, and expect that things will not change that much. But turns out, again, models suffer a lot, right? And there's a huge variance. For example, Bert is really, really robust to these kind of changes for whatever reason. We don't know that yet. But some of these other systems, including Roberta, which is supposed to be the better Bert, is suddenly much worse on these kind of problems. What this means is the sentiment somehow becomes more positive when you add these negative terms. Let me give you maybe one quick example. This is a exciting one that sort of tells you why sentiment can be a little bit tricky. Here are inputs where we start with a negative phrase and then change the sentiment by adding something at the end. So I used to hate this airline although now I like it, or in the past I thought this airline was perfect. Now I think it's creepy. And you can see the failure rate for all these models is really, really high. They think these are...
Yeah, but Samir, that's no knock against the models. This is a knock against the whole paradigm of the task.
Yeah, I mean, no, I guess, sure, yeah, like depending on but it's still a problem, right? Like if somebody is thinking of deploying sentiment analysis, and they expect these things to be working, they won't work as you
Yeah,
expect.
but that's just because we're all quite foolish about sentiment analysis.
Yeah, maybe so.
If your task is to predict the star rating on an Amazon review, you got your problem solved. You have the data you need. For anything else, you don't.
Right, yeah. But some of these products are being sold as, like, on Twitter, we're going to look at tweets and find sentiments. And so, for example, an airline might deploy this to see, okay, are there negative sentiments about United Airlines on Twitter? And we're just showing that these kind of things are not very reliable.
Yeah, sentiment analysis is one of the hardest problems that
Right.
we work on at Primer, and we've kind of shelved it for the moment. Honestly, it's very hard.
Yeah, I think sentiment analysis as a task is kind of busted. But one of the things I found interesting in that presentation there from Samir was the first bit, replacing one neutral word with another. And it breaks the model. That shouldn't happen. Like, they should be more robust than that.
And just to be clear, like, we are not focusing on only doing sentiment analysis. We did this for question answering that has been, we've beaten humans on squad, like going on 4 years now or something like that. And on paraphrase detection, which is the task where machine learning models are highest above human on the glue leaderboards. And on all of them, you can just literally write a few examples and you'll see that it's really bad.
Sorry, Samir. So this is, you're showing checklist.
Yes.
Yeah, sure. So I guess, yeah, about, I guess, jumping hugely to, obviously the exciting news this year, which was GPT-3. And I just wondered what your opinion on GPT-3 was and its potential impact, if any, on NLP. If anybody's willing to venture an opinion on it.
I have strong opinions, but I want to give airtime to other people.
I'd love to hear from someone who doesn't think it's interesting. Do we have anyone on our panel that thinks it's overblown? John, yeah, I knew that. Charlene, you agree with that?
Yeah, I think it's a little bit overblown. I mean, it's like better GPT-2, right? It's still not really like solving any fundamental problems, like as Tom mentioned earlier, common sense. It's just bigger and it can do like a wider range of things now, like code, because it literally has just seen more data.
I guess to be contrarian, no. So I think the hype is overblown and I'm not gonna defend that hype. I'll just tell you what I take away when things like these come up. And I think the few shot learning aspect of GPT-3 is something that's new, or at least newly demonstrated, right? It wasn't something that was shown for GPT-2. And just to be clear, what I'm talking about here is being able to take these language models and perform a task like sentiment analysis or question answering or whatever you have without needing any fine tuning, right? The notion of being able to do classification tasks without doing fine tuning is pretty new. And maybe GPT-3 is only, they've shown it does pretty well on some tasks, really bad on other tasks, but let's not focus on GPT-X. The point is that it does imply something for what the future, or some part of what the future of NLP might look like, which might be to get away from fine-tuning, because fine-tuning comes up with its own headaches and sort of management and all of these things you guys probably deal with every day. But also, so yeah, sort of implies that maybe there is an avenue to not do fine tuning and just rely on conditioning and prompting or priming. I guess there are many different ways to phrase it, that can still give you a lot for very little.
I don't think zero-shot classification is a new thing that's exclusive to GPT-3 though, right?
Not zero shot. I think the few shot aspect is important. Few shot where you condition it, you just give it input output pairs, and then you let it just give it the test input and let it generate the output. That I think is fairly new.
Yeah, so I've not got a lot of experience with language models, but it was interesting, the experiments that Melanie Mitchell was doing with analogy. And GPT-3 wasn't as good as her sort of handcrafted copycat system, but it was not actually bad, and it wasn't trained on that. And there was also, some aspects of it being able to do some limited amount of arithmetic, although it wasn't 100% certain that it hadn't seen those kind of examples out in the wild.
I was convinced. I was convinced by that section of the paper, actually, that they had indeed shown that it had learned arithmetic in some sense. Because they did increasingly long sequences. It seems like a really nice kind of defense of their arithmetic learning.
Yeah, I mean, there was a contra-review by, I think, Emily Bender and her co-authors about sort of overblown claims of language models because they're not grounded. Yeah, it was just, unfortunately, a lot of the examples on the internet are handpicked. So you can think, wow, that's amazing that just a language model can generate that. But it does seem to exhibit some slightly interesting behavior in that a lot of these tasks, things like inference, it's not very good at, but it is capable of doing some limited amount aspect of that, and even though it was never trained on that. So yeah, I found it interesting, yeah, not sure where to go beyond that unless to make it 100 times more bigger and see if it does something even more interesting.
Well, yeah, and wasn't that kind of the point, right? Like, let's add an order of magnitude and see what those curves do. And what I find funny is that the exact same result from the paper makes people feel exact opposite things. On the one hand, you have the celebrators who are saying, isn't it just amazing that you make these transformers 10 times larger and it's not leveling off? They're still improving on all these things you care about. And then you have the other camp that I'm in, who is like, oh dear, we have to make it that big just to make it like be able to do a little bit better on stuff we don't really care about. Like, what a pity. I'd hoped it would just sort of wake up and start killing people at this point. But it looks like you need all of NVIDIA to do the next experiment in this silly series.
I want to ask Samir, if I'm allowed. So isn't it true that the more shots you learn, the more shots you give, it will learn more? I mean, why few? Why not more than a few?
Yes, but although there is sort of a plateauing effect kind of thing, I think the interesting part with the few shot stuff is that there is no fine tuning going on. So there is no sort of like this training phase. You're not changing any weights. You're not you're not fundamentally changing the model for what that's worth. And so it's difficult to say, and this is sort of what we are sort of struggling with, like, is there even few shot sort of learning happening or not, right? Because you're not changing the model. So given the fact that you can only, GPT-3 only looks at certain number of tokens, that's all it is conditioned on. So you can't put in 1,000 paragraphs or documents and things like that.
It's not learning at all. I think that's the confusion, Samir, is that people sort of use the phrase few shot learning, but that's not what it's doing. It's few shot inference.
Yes, few shot inference, right? And given that it's doing few shot inference, it is kind of surprising how well it's able to do. Yeah. And what that means for NLP in the future is interesting to think about. Yeah.
I'll bet it's the future of silly chatbots. It's certainly the future of AI Dungeon.
Right.
Yeah, I mean, it's interesting that it's one of the examples of where unsupervised learning is actually doing something really interesting, because Jan LeCun, keeps saying that unsupervised or semi-supervised is the future. What's your perspective on that? Because a lot of us are kind of used to handcrafted labeled data. Should we really be exploring unsupervised and semi-supervised in a big way and trying to see how we can fit that in?
Tom, you've done some really cool work on that.
Well, yeah, I almost want to count myself out of this discussion now because I'm an AGI true believer. So I think unsupervised, fully unsupervised is the only way forwards.
Over the mountain range, though. We have to do a lot of useful things to pay our way there.
That's true.
That's why Primer exists, really.
Yes, I would say, like, I would agree with that. And by doing BERT, I think everybody's already kind of doing semi-supervised or those kind of things already, because it's trained on a lot of stuff. But this few shot inference is, since you're not learning anything at test time, is in a way unsupervised learning or self-supervised learning. And then, so yeah, clearly optimistic about where that can go.
Yeah, just so few just to add more context to that from the industry perspective, there's just so few useful things you can do with truly fully unsupervised approaches at this point still. Like most of the bang for buck comes from the hard way. Make a really good data set that represents the problem you care about, and then use one of these really powerful transformers to actually get it done. That's where we are largely day to day still. But you know, we do have the true believers among us. So we're keeping our eyes open.
Yeah, and just to add to that, like the process of creating a really good data set should not be underestimated. It is literally like a month or multi-month long task because data quality is just the impossible problem where it's like, as soon as you need to start scaling up your data labeling to where you need thousands of data points, it's like, who's going to check all these data points, you know? It just becomes really difficult to make sure that the same annotation rules are being abided by. And there's just a lot of overhead and administration that goes into it. And so as soon as we don't have to worry about that anymore, it really like unlocks the potential of NLP at so many different levels and for so many different use cases, especially for places that really just don't have time to have someone managing data labeling.
Do you have a top 3 lessons learned, or you know, these are some non-obvious things we've had to do to get high quality labels?
Oh, top 3 things. That's
or
hard. So consensus labeling is obviously helpful. You know, for some tasks, I've even gone as far as having 5 labelers look at each data point. And then take a threshold across the 5 labelers, which was usually 3. And then after that, I have my labeling manager go and actually look at each of these annotations and mark them correct or incorrect. And so that's about the closest that we can get to like an expert level annotation, like from one of us on the team.
I'd say another thing, Charlene, that you, if I were adding to the top kind of learnings from our arc at Primer with data labeling, it would be the importance of a trained data labeling team over a crowdsourced or ad hoc team.
100%, yeah. Like if you're doing anything of even mild complexity, you really don't want to be using mTurk. You want to be using like consistently the same people. Like even for us, we have this whole like managed team that's available to us, but like when someone leaves one of the labeling tasks and we have to train up a new person, you know, the quality goes down because that new person doesn't really know what they're doing at first. And so it requires like a couple rounds for them to get in the right rhythm. But I would say, you know, cultivate a really good group of annotators who you trust and make sure to constantly be training up new labelers on tasks that you're doing often. So if you have like a continuous training and eval pipeline or something that you need to maintain, you should also be continuously training and evaluating annotators to go along with that and to make sure that you're not going to have like annotator quality drift over time in addition to like model quality drift.
Isn't it funny how the science of educating humans has become like absolutely mission critical for machine learning?
When you mentioned earlier that you were doing like consensus labeling with 5 labelers, was that the trained, the highly skilled labelers that you're describing as opposed to crowdsourced?
Yes, it is. And that's necessary for a task like NER where there are just immense numbers of edge cases, like tens of thousands of potential edge cases. And so literally, the instructions that I wrote for NER are like a mile long, because I'm kind of enumerating all the different rules for, like, in this case, it's a loc, and in this case, it's an organization. And like, there's just so much that you kind of need to cover. Oh yes, named entity recognition. Sorry for not illuminating that, but for other tasks, it can be quite a bit easier, and you only need a couple pages of instructions, but you really kind of don't know until you try having someone label for the task.
So I guess if you're sort of building your own data set and labeling, how do you deal with this important issue of bias? Obviously, there's a wide variety of biases, but yeah, just wondered how you put that into your pipeline.
What kind of bias?
Well, it depends on what corpuses that you're using, but if it's English or if it's in certain, particular domains, it may be that it's obviously the most obvious one is racial in some way, or kind of racial profiling and things like that. But it can be anything from, obviously if it's vision, then it may be that it doesn't cope very well with people who have low vision. If it's speech, then perhaps people who are slightly harder of hearing and how it copes with dealing with that. But obviously the bias, it depends on your particular data set, but you have to be cognizant of, are there any inherent biases in it?
Yeah, absolutely. We actually, John mentioned this in the chat, but I'm actually heading up a project on whether or not our co-ref model and our co-reference resolution model and our named entity resolution models are biased in terms of being biased against Western versus non-Western sorts of entities, since primarily the training data that those models have seen are kind of Western and very like English language world based. So far, the results have shown that the named entity recognition.
And gender. That's the other.
And gender, yeah, that's right. Interestingly, Scale AI did some work on this, and they did find that when you train a model on Connell only, it's worse for female names. That's for the named entity recognition task. We found that our NER model was not biased in terms of Western versus non-Western, except that for some non-Western publications, it makes more mistakes on organization entities than it does for Western publications. And it wasn't actually because of any sort of language or racial or ethnic difference. It was mainly just because of writing style of those publications and the kind of entities that were mentioned in those publications. And so one learning from that was that we do have more work to do there, and that we want to expose the model to more different kinds of entities.
And Nick, can you just give a thumbnail sketch of your experiment on gender bias in co-ref?
Well, yeah, I guess like it's been well documented that a lot of pronoun co-reference models, that is models that take words like he or she and map them back to the person they're referring to, do have a bias against female pronouns as opposed to male pronouns. And we were actually lucky in that there was a whole data set and challenge, the GAP data set, gendered ambiguous pronouns from Google, where they were specifically addressing this problem. They released a high quality large data set that was balanced across gender and set up metrics to track gender bias in co-reference models. So I guess we were able to kind of get for free like an unbiased data set and get an unbiased model out in the end, which was, yeah, convenient for us.
And we're doing a bunch of follow-up experiments, by the way, for those curious about bias measurement. We're going to put out a paper about it once we've tied this all up with a bow. But one of the approaches we're taking is we've made a very big multi-ethnic name database of given names and surnames. And we're doing substitution experiments to see, we're just basically trying to perturb our model by substituting names to see if we can make gender co-reference or NER have bias and if it's measurable. So that's underway.
Yeah, that's really interesting. I don't think checklist does anything with bias, does it, Samir? It's really...
We have some experiments that show that there is a lot of bias. Also, we didn't quite highlight it, but we tested question answering systems, QQP, which is paraphrase detection, and sentiment, and all of them had pretty much any kind of bias you would throw at it. So we looked at gender bias, and then the usual stuff of professions being associated with a single gender, which statistics aside, when you give it an unambiguous sentence, it should not be biased, but it is. And even for question answering, we would say John is Mary is a doctor, John is not, who is a doctor as a QA task, and it would say John, right? Things like that. So we tested those things as well. And all of these models had those inherent biases.
That's great. Thanks. So a little bit of a tangent. I mean, all the people that I come across, they're all pretty much computer scientists who are working in NLP, people interested in deep learning, but we don't get a lot of input, at least, or statisticians from computational, if you have more from neuroscience or cognitive psychology. I know perhaps the understanding of the brain is obviously still fairly primitive, but do you think we should involve more of those guys in this area, or at least get a perspective?
Well, what comes to your mind as an example of that kind of cross-field?
Well, I've recently been watching some of the videos by the, I think it's the Center for Minds, Brains and Machines at MIT. And they've got quite an interdisciplinary group. They spend a lot of time kind of thinking about how the brain processes certain types of information, how language is sort of processed. Unfortunately, obviously, language is not very well understood. Vision is much better understood. But yeah, those videos were like really quite interesting and thought-provoking, but they didn't have any direct actionable thing that I could actually apply. But it was only serendipitous that I was looking at those. And as I said, virtually everybody I come across in NLP doesn't really show a lot of interest in that aspect. They would rather just look at data sets and, label data sets and work on those. And I just wondered what your perspectives on that was.
Yeah, I'm married to a clinical psychologist. We do have some very good conversations about AI. She's not working in the field though. But I definitely think there's stuff that we can take away, right? I mean, you've got people like Jeff Hinton working on spiking neural networks. It takes inspiration direct from biology. And I think that's great. That's stuff that we're going to need to do more and more going forward if we're to break out of this, what you said, what you called a local minima. So yeah, I personally, I'm interested in neuroevolutionary strategies as well. So definitely, yeah, taking a lot of inspiration from the biological world.
Yeah, I mean, one thing that interested me was how different the biological world is, where there is so much feedback, whereas we don't really apply feedback in most of these state-of-the-art models at the moment. So yeah, it was, as I said, because the brain is so little understood, it would probably have to be, just making what use you can out of some of those ideas and seeing what you can apply, with them. I think I did come across an AI company that was using more brain-based. Their name sort of, I forget that, but they had kind of state-of-the-art models.
You're thinking of Vicarious?
Yes, that's right. I am. Yes.
Yeah, isn't it still just an open question of whether the neural network solutions that biology seems to have discovered and exploited on this planet are the only solution to intelligent problem solving? That's really what we're getting at is, would it be possible to make intelligent systems that are as capable for tasks we care about that are nothing like the neural systems that biology has used? No one knows.
Yes, an interesting question. Although biology's had a very, very long time to play with that stuff. So it would be interesting why it felt the need for a lot, this massive amount of feedback, whereas we don't need it for as much, at least for vision, because, our vision systems are pretty close to what human vision is in some areas now.
although doing machine learning, it's hard to imagine that doing machine learning as human practitioners is a sort of evolutionarily relevant skill. So, at some point, biology doesn't care about what you care about.
Actually, I had a question for some of you guys who are in practice. Do you think your evaluation methods are robust, or do you think they still need sort of quite a bit of work?
Ooh, Nick, I know you have strong feelings.
Well, yeah, I guess like one thing that we've kind of learned through making various models at Primer is that it's very hard to come up with good evaluation metrics for your models that actually will represent how your model actually performs in the product. It's like a bit of an open problem, really. Like, how do I collect the data and make sure that it really represents what we're looking at? And I think that something that we overlook a lot in machine learning is just simply having a high quality validation and test data set. There's so much focus just on getting really good training data. But I would say it's just as important to be able to have good, high quality validation data through which you can select the correct model, and good test data so that you're actually able to know how it really would perform in the end.
Yeah,
one really important thing Nick has done towards that for us is implementing confidence interval evaluations for all of our evaluation metrics. And so now if we have two models that the overall accuracy is like 91 and 92% or something like that, or I don't know, let's say 91 and 93.5%. If you have a confidence interval that overlaps, they're not significantly different. But if they don't overlap, then you can say the second model is better.
Yeah, until we got serious about statistics, I think a lot of our energy was directed at chasing noise, and I think the whole field, so it's sort of shocking how much statistical know-how there is in machine learning, and yet the practices of statistics seem to have been like cherry picked. It's like, oh, error bars, that's not relevant because this is math. It's not true.
Yeah. No, that's really interesting. So I wanted to ask you guys, what is your biggest problem at the moment? What's the most challenging thing that you're working on at the moment?
Samir,
if anybody wants to share their biggest bugbear.
We're all of us here from Primer are kind of working on the same set of things. So maybe Samir, you go first since you're the most different from us.
I guess, well, I would like not to be too different from, I hope we're all trying to make NLP just better. But so yeah, let me know if I'm way off, I guess. I think there are a couple of things that we've been struggling with. So there are sort of three aspects of how I approach NLP. One is interpretability, evaluation, and modeling. In modeling, some of the ideas that came up earlier, how do we combine knowledge that we may have available symbolically and not available in text, whether it's in a knowledge base, knowledge graph, or some other database. How do we combine that while we are doing language modeling so that we get these models that just know things, not just stuff that they've literally seen in text, but also stuff that may be available symbolically. So how do we build models that do that? On an interpretability point of view, we've been thinking a lot about what are the right explanations that would be useful, especially for text, because a lot of the explanation methods we use in NLP, including the ones that I've been using, have originally initiated from vision and even from tabular data sometimes, like LIME and saliency map and things like that, which have been applied to text, but they don't seem like natural fits because text is a whole different beast. So thinking about what do explanations look like for text is one direction. And on the evaluation kind of things, how can we make it really easy for people to know how good their model actually is, right? So checklist, I feel, was our first step in that direction, but how can we make it easy for people to know what their errors look like? How can we make it easy for them to write their tests so that it actually covers the whole spectrum of what the model is wrong at? And even sort of going back to earlier point of annotating, how can we make it easier for users to create good evaluation data sets that are actually probing different parts of the model and not just sort of having a template and replacing a name and then just sort of creating data sets like that. So those are sort of the higher level directions.
On my end, I divide my time between running a machine learning team, and so you know, it's like how can you keep a team that is astride both research and application, healthy and productive and happy in a company that has to make money. So that's kind of like something I just spend a lot of energy trying to get right, less wrong. But I do have a chunk of my time that I keep protected for IC work. And for that, my obsession is summarization. I'm just obsessed with getting summarization to work and be factually correct. We've gotten to the point where it's fluid. Our current model of choice is BART, and it's just doing a bang up job of making fluid, relevant summaries. But it doesn't always get the facts right. And when, you know, our customers are analysts whose job is to read and write and then help people make expensive decisions. And you got to get the facts right, man. So that's just my obsession, right?
Sorry, John, is that abstractive or extractive summarization that
you're
referring to?
We've done the whole gamut. We've done extractive, fully abstractive, and we even made something. We have a scientist in our team named Oleg, who's come up with a brand new approach, which we call semi-abstractive, where you are able to say whatever you want, but you have to use the vocabulary of the document. We've tried it all, but yeah, right now we're doing fully abstractive summarization with BART, which everyone can see by going to labs.primer.ai. You can play with it yourself and see all the ways that it's impressive and, you know, not impressive. But
great. I think I'll play with that. It's one of my little pet obsessions as well.
Yeah. But every person on my team is working on a different problem. I'm so glad that Sam, you let me pull in a big gang, because they cover a really broad territory of NLP problems. So definitely want to hear from them.
Well, I'll go. My fascination is QA, question answering. And I think if we can solve question answering, there's a lot of other downstream problems that we can use that to solve, like what Charlene said about we're using QA for relation extraction. But what I've seen is the big problem with QA. Well, firstly, two problems. The state-of-the-art model for that is still SpanBERT, which is kind of getting a little bit long in the tooth now. And it's kind of stuck at this like 85% F1 score barrier that it just seems really hard for any NLP model to overcome. And the second problem with it is how do you get a yes or no answer to a question from a QA model? Like, you can extract the span of an answer within the text, or you can use abstractive models, and we've played with that too to see if they can get better at answering questions. But nothing is able to give a clear, direct answer, yes or no, to a question. And, you know, going back to my earlier point about understanding in language models, I think that may be the missing piece. So although, you know, we keep trying lots of different approaches, I'm not sure this is quite a solvable task at this point.
So the thing that I spend a lot of time thinking about at Primer is, you know, we have all this really amazing tech. Like, we've had a research team for a while. We have a bunch of great NLP models that can do some really interesting things. We can use them to extract structured data from unstructured text, but they're big and they're slow. And so when it comes to the volume of documents that we're processing every day, it's just not viable to run a bunch of like gigabyte plus models on them because otherwise that would be very expensive. And so one thing that I really want to figure out or help us figure out as a company is like, how do we actually be clever about including these into our systems and still get the structured data that we want and that our customers are looking for? And so I'm kind of, that's sort of my side interest besides actually like working on training and productionizing models.
I guess to kind of wrap up what everyone here is working at from the Primer side, I'm kind of between projects, but I've most recently been working on a project where I try to understand disputes of factual information and tease out what the different sides are to dispute, if certain people are disagreeing with other people or if they're on the same side. And I started by, I guess, hoping I could basically adapt the NLI problem to that, basically recognizing if sentences entail or contradict. But what I realized is that the data sets for that are ridiculously specific. Like, you know, the two biggest data sets are based around either photo captions or like very oddly specific genres, like, you know, reports from this one convention or like, you know, telephone conversations from this one time. And they have all sorts of weird assumptions baked in, like everything that can be talking about the same thing is talking about the same thing. So there was all sorts of challenges as to how do we get, you know, high quality data while still leveraging the data that we have, seeing as there's a ton of it.
Yeah, that's really great, and that's really interesting. All the different, you know, aspects of the pipeline, and you know, the different problems at each aspect of it. Size of data is definitely something that obviously I struggle with because my budget is a lot smaller than perhaps you guys. I guess one of the elephants in the room is sort of any sort of common sense, because a lot of these models make silly mistakes because they don't have any of that. I mean, do you guys have any perspective on how you could incorporate any aspect of that? I mean, I know it's a open research problem, really, probably asking for way too much.
I have a hunch that we need many models to communicate and somehow evolve their own language. I have no basis for that. It's just a hunch. But as for solving common sense, like, I don't think anybody's got a clue at the minute. I mean, I'd like to incorporate maybe visual stimuli with language models. That might help. Adding some kind of recurrent layer to the bottleneck in the language model, that might help. Like, there's a lot of different things that we could try, but just not enough time. I hope academics are doing all this stuff.
I would agree with that. Like, I think a lot of what we mean by common sense is often stuff we don't directly express in text. So there may be an argument, and I'm not making it, but there may be an argument that there may be an upper bound for how much common sense you can learn just by language modeling, because there are just certain things you never say. Of course, this sort of depends on what the data is, and common sense on Reddit may be very different from common sense that we share in real life. And so looking at vision, looking at other modalities, video, audio could give us a perspective, or by us, I mean machine learning models, could give them a perspective on the world that they wouldn't otherwise have access to through text. And so, yeah, I would agree with that. Yeah.
Yeah, I did put that in as a little bit of a curveball because it is a little bit of an obsession of mine, but as you guys say, haven't got a clue as to how to incorporate.
Well, Arshad, one thing that I always wonder when people bring up common sense is, what do they really mean by that? So common sense is not a task, right? Common sense, like, how would you measure common sense? Well, okay, I'll make a benchmark. Well, once you make a benchmark, you're actually making a new task, right? You're not measuring. This isn't the task of common sense. The way, how would you test common sense? You'd have a series of statements, and then you're supposed to decide whether they're sensical or not. Well, okay, now you're doing NLI. Okay, well, no. I'm gonna do photo captioning, and I'm gonna tell a story. And if you can guess what the next, what the answer to my question is about this story. Oh, darn, we just made QA. It's like, how do you measure common sense? Isn't really just common sense the god of the gaps when it comes to machine learning?
I guess so. I mean, I originally came across it when looking at Vinograd schemas, which are fairly sort of simple for humans to do, but machines find them really still quite difficult. I think the maximum score is around in the early 70%, so there's still a long way to go. But you're quite right. I mean, in virtually every algorithm I've looked at, like named entity recognition or sentiment, the missing element seems to be that there's a trivial bit of information that the algorithm is not taking any account of because it was just not trained in the right way. And if it had that some additional information about the fact that what he was saying was nonsense, it might help. But you're quite right. It's such a huge, what is common sense? Yeah.
We have a question that came in through YouTube that I think we started answering in the chat. I wanted to give everyone a chance to answer over the panel. This is from Brandon Lee. Is there a movement to integrate reinforcement learning integrated with NLP?
Oh, right. I just realized that Brandon Lee can't see what I'm writing in the chat, can he?
Right.
I've been trying to communicate with you, Brandon. Charlene, you had a good answer there. You want to just let him know?
Yeah, totally. So yeah, I linked this paper in the chat. I guess it's actually a blog post summarizing the paper, but it's out of OpenAI. And what they did was they trained a summarization model using reinforcement learning and incorporating human feedback to sort of tell the model how good their summary was. And so if you look at the results in the blog post, it's like pretty clear that the RL trained model is better than the supervised model was, like the model trained in a standard supervised labeled way. But the practicality of their method is still pretty questionable at this point because it required like an enormous amount of compute, which is just not viable for like anyone else besides OpenAI or Google or whoever. And so I think that's part of what's kind of limiting RL from really making an impact in NLP at this point. There's definitely a lot of interest there and it's becoming kind of trendier, but I haven't really seen like the silver bullet that actually makes RL-based methods viable for the rest of us.
All right, guys, I think that we're going to start wrapping up soon. So I want to let everybody know that if you have any questions you've been hanging on to, make sure you send them in. We got a few more minutes that will stick around, but be sure to send that in. We're monitoring the YouTube chat as well. So see you soon.
Well, in the spirit of why hasn't technique X approach, appeared in NLP yet, one thing that I've always wanted to see happen is some analog to a GAN arriving in NLP. The best answer I've seen for why no one's figured out how to make a GAN work with NLP comes from Ian himself in a Quora answer of all places. You should Google it. It's a great, succinct answer about the fact that you can't treat words as real values. So unlike the word penguin, you can take a pixel and slightly perturb it one direction or another in its dimensions. You can't make penguin just slightly different from penguin. You have to go to a completely different bird or a completely different word altogether. And that's sort of the fly in the ointment here. But we've been noodling about this at Primer, about different ways you could have adversarial learning to at least, for example, have hyperparameter tuning, move a text generation model towards better and better text generation. There may be some tricks that we're just not thinking of, but I mean, it's hard to look over the fence from NLP over at computer vision and see all that beautiful GAN generated stuff and not get jealous. Like, what are we missing? How do we get there?
I'm guessing word vectors are a little bit too coarse. If you move a little bit further away from penguin, you're going to end up at another bird. It won't be some aspect of penguin.
I'm curious, I think it was you, Tom, who mentioned an interest in ML ops. Are there Yeah, maybe if you could talk about the intersection of ML ops and NLP. Are there specific things that you need to think about when you're applying, when you're trying to operationalize NLP?
Yeah, I mean, these models are huge, right? And they're often quite slow. So from an ML ops standpoint, you need to look at a couple of different factors. How do you keep your latency down? So how do you quantize models? How do you convert from PyTorch into Torch script or Onyx format? Things like that. Can you use FP16 inference? These things. And you also need to ensure GPU utilization, of course, as well. It's pretty useless to have a 2 GB model on a 16 gig GPU. You're wasting a lot of time. So compressing all of these models onto a single node in Kubernetes terms, that is a very big challenge, as is batching as well. We want to be able to do batch inference if we want to scale. But when users' requests are coming in at unpredictable intervals, that's a real challenge to squeeze the efficiency out of your GPU.
Hey, just throwing one more piece of color on there. One of the real practical money-saving wins for us in that vein was when we went all in on multi-label classification. So it's very easy to lose sight of the fact that all of your different classification tasks don't need to all live in different models. It is actually, these transformers are so over parameterized, they're quite happy to learn many, many tasks. And you can load all of that into a single model without deal-breaking degradation in performance. And now you can support many, many tasks on a single node. That's been a big practical win for us. And actually, Nick is looking into some of the fundamentals of that to make sure that as we scale up the number of tasks that a model is learning, we're not going to have catastrophic forgetting. So
that's interesting. Is that still a standard-sized BERT model that you've used with some kind of a back-end layer for each of the different multitasks, or have you had to actually make the model itself bigger to do all the multiple tasks?
No, not at all. Single model. I think so far our most successful vanilla doc classifier has been ExcelNet as a base, but it could be sort of anything, and they're fully capable of learning multiple tasks.
That's really interesting. And in terms of ML ops, it's almost like what you need is some of this student teacher type model. So you could have like the main one which you've trained for a long time and then somehow compress it before it goes off to production. And if it's sort of 94% rather than 97% accurate, is still okay. But yeah, it's a really interesting problem.
I think we have Robin here for a second. I want to make sure you had a chance to ask a question in case that's
Hey, I don't know if my mic's working.
Yeah,
my mic working? Oh yeah, I was just wanting to ask John if you've seen any accuracy actually increase from doing multitask, because it doesn't have to go down, right?
That's right. Well, in the spirit of statistical honesty, we cannot distinguish the performance of our multi-label model from our single label model, and we're very happy with that.
Cool, thanks.
Do you think it actually increased the quality? Because there was a paper which I read recently which was fine-tuning BERT, which seemed to imply that multitask may slightly increase. Right. Also depended on some cross-domain and in-domain training on top of that as well.
It's very conceptually appealing, of course. You can't help but feel that you have you can't help but have a metaphor in your mind when you think of multitask learning, that learning how to do this task will surely help to learn some other task, because it is just language. And often tasks, are not orthogonal at all. In fact, I don't think there is an orthogonal task in NLP. I think that's the big lesson of the language models. But until I see robust performance increase due to multi-label, I'm just trying to stay agnostic.
Your previous comment about multitask, are you using multitask and multi-label classification interchangeably, or have you tried more divergent tasks?
Yeah. Good catch. Really, practically speaking, we've done multi-label classification and nothing else. For us right now, what customers are willing to pay us for the task that we're solving for them, it's not prohibitively expensive to just have another big transformer model sitting in another node doing the job. But with classification, we are on a scary trajectory in terms of the number of new classifiers per doc that we want to apply. And so that's where we've been putting all our energy, is just making sure that we're doing multi-label where we can for classification.
One interesting finding. Oh, sorry, go ahead, Nick.
Oh yeah, just to give more context behind those experiments. Basically, we had like 8 or so, maybe 10 different classifiers that were all like basically different categories of news that was all jointly somewhat related to COVID-19. And there was a decent amount of correlation between these labels that we're actually able to measure. And I think, while we can't say, if this was statistically significant or not, it did seem like training multi-label might have improved the performance on some of them. But like seeing as these models are so overly parameterized, like we really don't need a whole BERT model to be answering simple questions about a document, if you ask me. So I think it would be interesting if we could just fit, completely different tasks onto the same model. Maybe we could have a model that does classification and also NER, with just a swap of a layer at the end. And if we just train them to do both of them, it would be interesting to see if performance actually does degrade.
And text-to-text models may be the answer for truly diverse, deep, multitask learning. We don't know.
So going back to GANs for text, like isn't GPT kind of like a generator for a GAN? Like what's missing there?
Nick, you wanna do
a
mathematical ambush?
Yeah, well, I mean, okay, yeah, I guess it is a generator. Like it is a generative model that generates text. The problem is that in the whole GAN formulation, you want the discriminators, I guess, like decisions. You want to be able to use that in order to train the generator end to end with gradient descent. And when you're performing, I guess when you're generating text with something like GPT-2, you are you're coming up with some kind of distribution for words that you want to come out, and then you have to sample from that distribution. And that one sampling step is kind of what breaks the GAN formulation when it comes to text, because you can't, I guess, calculate gradients that go through that. You have to come up with something, significantly more clever. Like I think there are people who have tried to adapt GAN-like formulations to text, and they've done stuff that introduce different concepts from reinforcement learning or elsewhere. But I don't think that's where the most success has been from generative text models.
Thanks.
Well, I've got a question if folks are getting quiet in the chat. Samir, I would love to hear, how has it been? I come from academia before industry, and it seems like it must be a strange time where just over the course of sub-career, like just in recent years, you've gone from a field that looked and smelled like a traditional academic field with all its rich ecosystem of students coming in, professors and postdocs and internships, to being completely taken over by industry. Not completely, but like huge colonization from industry. They run the conferences effectively. They, not all of them, but they grab all the students away for internships. They grab all the postdocs away into jobs. Do you feel embattled? Do you feel enriched? Like, what is it like from your side of things?
That's a good question, and that sort of changes every time there is yet another big player that comes into the picture. So my answer might be very different next week than it is today. But overall, I think it's been great, actually, right? It's been a net positive. I think there are some problems that do overlap with what industry cares about. But for the most part, everybody's trying to do interesting stuff in NLP, and there is having more applications and more of an audience has just given rise to more research questions. So I don't think there is so much of like, hey, there's nothing left for us to do kind of sentiment. I think it's a lot more of, wow, this crazy thing happened and how can we do next, right? And partly I think a lot of the work is coming from industry, but most of those people are ones that were in academia. Like I did my PhDs around the same cohort and things like that, right? So they don't feel as alien to me in any sense. So yeah, no, I think the research problems have been pretty exciting, the ones that we have been looking at now. And the one sort of, again, not a shortcoming because it has been good for NLP overall, is the sort of computation requirement that is now needed. It has made it difficult to do certain kinds of problems in academia. But I think that's true for many industry places also, right? Like I think unless you are in a big company, like GPT-4, for example, it's probably going to be Google, Facebook, OpenAI, or maybe Apple and Microsoft or something, right? That's it. Like, you're not going to see GPT-4 coming out of that. What that means for the field has its negative, but I think from our point of view, we're adjusting. And overall, it's been a great positive thing for students. So they have jobs that are well-paying jobs. They have internships, and all of these are, to me, very positive things.
We have one more question from YouTube that came in from Navneet Kumar Chowdhury. He's wondering what the best approach is for getting some structure out of unstructured text for cross-domain data, knowledge graphs, keyword extraction.
Cross-domain data. I wonder what's the spirit of that?
I feel like this is the question that Charlene answered earlier, right? When we're doing research on relation extraction in our team, we've productionized that. And we're able to go through news data and pull out all of the relations that we care about. And we're doing that by leveraging the question answering paradigm. So I don't know if maybe Navneet missed the earlier part where Charlene sort of dove into that a bit deeper.
Yeah, we asked for a little bit of an elaboration. He said data coming from many sources.
Oh, many sources. That's interesting. Yeah, so it's hard to make a model trained on a specific kind of data work for other data, as any practitioner has seen. So if you want to do cross-domain, I guess the short answer is, get data for all the domains and then apply question answering.
There's a lot of research directions that show promise for making cross-domain performance more performant, but it's really still research. I don't think anyone has cracked this nut. You got to label data is the current reality.
Yeah, I guess some of the work that has been interesting on that side of things is to feed knowledge graphs or keyword extraction or whatever you have by creating sentences, natural language sentences out of it and feeding it to language models because that's what they understand and sort of adapting them in some sense to be knowledge graphs. That kind of stuff has been exciting to see. And just could potentially give you a way to do this cross modality or cross data source stuff.
Just to give some actual concrete color to what it looks like to use Charlene's technique. It's actually Tom and Charlene's technique. Part of the workflow is to come up with variations on the question. I find it so funny that you have to have a certain finesse with words to be a good to be the most effective possible machine learning engineer when you're doing this kind of thing, because you're using a question answer model. Let's say that you want to determine whether a person has visited a location. So this is a model that Charlene actually trained end to end fully. She created the task, she got the data labeled, she trained the model, she evaluated it, she's got it into production. She had to figure out all the different ways you could express in English whether some entity, a person, has been in or visited or is located in some location. And then essentially like do parallel versions and find out which of those questions is the most performant. So, you know, if this sounds familiar, it's kind of like back in the day when we hand engineered everything and then slowly but surely hyperparameter optimization kind of sort of gobbled up that territory and you didn't have to worry about it anymore. I wonder how long it'll be before we have a generator model exploring variations on the question in order to get the best performance. You know, if we end up really going whole hog into QA-based relation extraction, I don't see why not hooking up a language model to do some of that work. Maybe crazy.
Thank you all. I'm going to chime in here. Unfortunately, we were running out of time, so we're going to have to wrap up. I wanted to thank everyone for joining us. Thank you, John, Charlene, Tom, and Nicholas for the Primer Dream Team here, and Samir for joining us. And Arshad, thank you for the moderation, and everyone for attending and asking these great questions. The video will be available on the session page in case you want to reference anything later on. And we do have a couple more office hour sessions coming up on reinforcement learning and another one on computer vision. So be sure to keep an eye on the agenda. And we want to give another shout out to our sponsors. Thank you so much for making this all possible, and hope to see you in the rest of the festival. So thank you again, guys.
Cheers, everyone.
Thank you, everyone, for coming.
Thank you. This was great. Yeah.
Thanks, guys.
So good to hear your voice, Sam.
Hey, thanks, John. Thanks, everyone.